This is a real privilege for me. We are here today with Dr. Werner Vogels. He is the CTO of Amazon, and of course has a lot of really exciting experience with that. And so we're going to be talking to him today about his experience with Amazon, about his experience with startups, and about lots of technical topics as well that will be relevant to many of us. So thank you all, and let's give it up for Dr. Vogels.
Thank you.
Okay. So we're going to be talking, of course, about Amazon today and about your role there, but I'd like to start with a little bit of background. Would you mind telling us about your career before you started at Amazon and sort of what brought you to that point?
How much time do we have? I was an academic before I joined Amazon. And so I'd been a research scientist at Cornell for 10 years, building very large-scale distributed systems. And as in common in American academia, you're being motivated to do startups on the side. So we did 2 startups on the side. One of them that already existed when I joined them, and they got sold off and were successful to a company called Stratus. I don't know if anybody remembers that. It's before your time. Yeah. And another company that actually failed. So we had both experiences. That was great. Kind of. So before that, so I'm not the typical sort of computer scientist. I wasn't until 28 when I decided to go back to school. I worked in hospitals before that, radiotherapy in the Dutch Cancer Research Institute, doing radiotherapy in cancer patients. And at one moment I realized that I really hated all these people dying around me. And so I decided to go do something that had no humans involved whatsoever. So computer science seemed like a really good thing to go into. And this is mid-80s. So, computer science is nowhere where it is now to today. But it turned out there
weren't any humans back then.
Put it like that, yeah. So, it turned out I had a gift for it. And I didn't know that up front. So, and from there I went into research because those were the kind of things that I really was interested in. Got my PhD, worked in Portugal for a number of years in a research institute, and then was invited to come to Cornell. And then at one moment, so what I did do around that time also when I was still at Cornell was actually either consult for large companies like the HPs and the Suns and whatever of this world. And also often gave talks. And so at one moment, Amazon invites me to come give a talk about sort of some of the material I was working on. And I think like, really? Really? Do I have to go? What is this? This is a bookshop. It's a web server and a database. How hard can it be? Yeah. One glimpse in that kitchen, however, and I realized that this is a massive technology operation. It's not a retailer. It's a technology company. And operating at a scale that I had never seen before. Definitely not at other companies that I'd consulted for. And so the challenges that they were faced with from a distributed systems researcher perspective were amazing. And so I didn't need to think very hard when they offered me a job.
Wow, that's incredible. So that's interesting. Do you feel like that was a change? Like today, sort of like the interesting distributed systems problems are kind of like huge companies, and maybe before it was academia, or was that just that's the way your career happened to go?
I think that still is the case. I think most distributed system researchers have become more aware of sort of the kind of scale that these very large companies need to operate at, or not even these very large companies. I think if you think about, any successful internet company or digital-only company needs to operate at a scale that is unparalleled. 2004 when I joined Amazon, I mean, many of you, if you're going to be successful, will be easily operating at that particular scale that Amazon was at in 2004. But there was no body of work that you could really rely on. There was no infrastructure that you had to rely on. So a lot of effort went into basically keeping the lights on things that cloud and other technologies now gives you. And so Amazon had gotten in 2004 to a scale purely by being practical. And it's not that there was a book or so that you could read how to build a scalable organization or a scalable company. No, it didn't. And so everything Amazon was sort of, in my eyes, 5 to 10 years ahead of the curve, both in terms of the usage of technology, of the development of technology, but also at the operational scale. And especially if you want to be a fast-moving company, it's not like you could look at traditional enterprises, because they are all sort of, suffer from innovator's dilemma and other things are really slow at one moment once they become successful. How to build a company that needs to continue to move fast is a whole different story. And so you may be doing things that, you may be making business trade-offs. For example, the creation of technical debt or the allowing duplication to happen and things like that, that would be out of the question in the traditional enterprise because efficiency is their main goal. At Amazon, moving fast and innovating fast and having a very long pipeline of experiments, that's the most important thing. So you're willing to allow duplication to happen. You're allowed to create technical debt as long as you know that you have to pay it off. So there's many trade-offs that Amazon has been willing to make over time that you can't find in a traditional MBA book. And so in most of these things, Amazon had to develop for themselves, and whether it's technology or whether it's processes or business processes. Now it helps, of course, that with Jeff Bezos at the helm, you have someone who's a true visionary and truly understands sort of how the next modern world will look like or should look like.
Thanks. So a couple of years after you joined, you were appointed the CTO of Amazon. And
6 months, actually.
Oh, really?
Someone asks you, do you want to be the CTO? You think he's not going to ask next year, is he?
Wow, okay.
No, so Alfie Mullen, who was still at the company, by the way, didn't really, he really wanted to be a developer and they had been looking for a replacement for him. And as I said earlier, sometimes you have gifts that you don't know about until you start doing them. And so I think I joined in September, and I think in January I became a CTO.
Wow. So tell me what that was like at Amazon, and then sort of what that role has shifted into as we get till today.
Yeah. So if you with an argument, so one of the things that at Amazon, sort of one of the reasons for hiring me, and actually a few of my, I brought 5 of my former students with me when I came there, was really to insert more sort of academic rigor into the way that we wanted to approach scaling. Where Amazon had become really good at scale, but the challenge was that we wanted to do orders of magnitude more. And in essence, when you go from order of magnitude growth, you have to revisit almost everything that you do, whether it's your processes, but also your technologies. And so to really be on a solid footing, to do sort of the next 1 or 2 orders of magnitude of growth that were coming, we needed to sort of insert way more rigor into our thinking. And it was, for example, around performance. How do you measure? What kind of infrastructure do you need for measurement? How do you, if you want to be a truly data-driven company that sort of makes data-driven decisions, you need to, first of all, have the data, but you also need to have a culture around how do you measure? And how do you interpret those measurements? I mean, a medium latency of, let's say, 1.2 seconds of your web page to your customers doesn't say anything. Just says that 50% of your customers have a worse experience. You need to know how much worse. And then, from an engineering, so for example, the 99 percentile or the 99.9 percentile is way more important often in those cases. And then, how do you create an engineering discipline that has control over that 99 percentile such that you can actually start pulling it in if that's what you want to do? And then be able to associate that with business decisions. For example, the common knowledge is that if you improve latencies of your web pages, conversion goes up. And so the question then is, how much are you willing to spend to drive that conversion up? You need to have more capacity. You need to do more engineering. And so when you have a diminishing return on sort of the investments that you have to make to get that control. So whole year we focused really on performance and measurement and things like that. There was a bit in progress already when I joined. We did a whole year on focusing on single point of failure. Really, I think in 2004 we were pretty good in terms of reliability. There were rules around, so we had to use 3 data centers. You had to replicate whatever you did over these 3 data centers. You'll be able to lose a data center. Customer should not be impacted. So you could lose 2 data centers. Customer can be impacted in terms of latency, but not in functionality. All of those rules were there, and I think we were pretty good at it. Until at one moment we decided, so why don't we pull the plug out of one of these data centers and see what happens? And the first time when we did this was not like we made it as a surprise. No, we gave everybody a heads up that this is what we're going to do. We're not really pulling the plug. I mean, you pull the network, basically. So data center gets isolated. Turns out all these things that look great on paper didn't really look that great in practice until the first time when you do it. Lots of manual processes, still manual database failovers, things like that. This is all pre-AWS. So that's sort of a whole year focusing on that. And so by the time you do the third or the fourth of these, what we call game days, you actually get to a point where these things become really well automated and that you can actually do them without human intervention. One biggest surprise when we did the first time was, and then you bring the other data center back online. And then suddenly that data center has to sync with the other data centers. Man, that's a nightmare. That was a scenario that nobody had thought about. And so, but until you do these things, you don't know them. And especially at scale. So, and then we did a year on efficiency. We did some other things. So mostly the role of a CTO is to drive really big programs and think about sort of what is the technology that we need for the future to be able to be on solid footing as a business. Or in the case of Amazon, what are the kind of unique technologies that we've developed that we may be able to turn into a business? Then things change at one moment because in early 2000, we had opened up the catalog. We put an API on the catalog. That was popular in those days. You just put an API on something to see what innovation happens. And it turns out lots of great companies were being built. So you would have access to the catalog, search, shopping cart, and I think one more functionality. Anyway, so lots of new e-commerce companies were being built based on the Amazon catalog. They would do comparison shopping and have wonderful new UIs towards the whole site. Really great stuff being built. But as soon as one of those companies became successful, they all started to stutter in the execution. They all needed to get investment, not because they needed to do the business operations. They all need to start buying hardware. And they need to hire IT people. And so all this investment was in essence, an indirect funding of the American hardware industry. Yeah, because and that was where and so all of these companies had hard time doing that. They had hard time getting the investment. They had a hard time getting the hardware because, you might order 50 servers. It's not like driving up to Costco and actually getting them in your shopping cart. It's, and then hire IT people and things like that. So most of those companies that were initially successful around the Amazon catalog all failed. And they didn't fail because they didn't have great ideas. They failed because they couldn't get their IT staff ready or get the money to actually do that. And I think one of the things that has shifted with AWS and cloud is that the investment that you get no longer goes in large numbers to hardware companies. It goes into hiring more people that are relevant for your company and actually build your products better. So then when you become, we started AWS and we can talk more about that later. But when you become a technology provider, your role as a CTO changes. I think there's I wrote a blog post once about that. In my eyes, there's sort of 4 different types of, first of all, ask any large company, every large company, the role of a CTO will be different. But I think there's sort of 4 large categories. One is in enterprises, they're often sort of the infrastructure manager. Yeah, they will report to the CIO, manages large amounts of infrastructure. And then there is sort of the second role, I think, is that of what you often see in younger businesses where the CTO is the technical co-founder, the one with the technical vision. I do think that role is a dangerous one because there's so many other things that actually fall into that bucket in terms of VP of engineering teams and things like that CTOs may not necessarily be really good at, but we can talk about that later. Then there is the role of a big thinker. That's really where you're sort of driving innovation. If you look at companies like AT&T and Lucent and others, they all had CTOs that had an office of the CTO that will be really building next generation technologies or experimentation there. And then there's the role of the external facing technologist. If you're a technology provider to other companies, there's a role for an executive to actually interact at a deep technical level with your customers to understand how are they using my products. Yeah, and looking for the bigger patterns among your customers. What are the bigger pain points that they still have? Not only with our technology, but just in general. If often jokingly said, so we're in we're in the business of pain management, AWS. Yeah, so what kind of pain do customers still have that they have to work on that actually don't contribute to the products that they want to build? And so that's sort of, on one hand, helping customers understand things, sort of being a bit of the evangelist for the whole notion of cloud, which definitely, let's say 10 years ago was much more important than that it is now. But then most importantly, take the feedback from your customers back and start thinking about sort of what new features or products or you have to do or what kind of processes we need to change to make sure we serve our customers better. And so it's a much more customer-focused position than a technology-focused one.
Great. I'm curious, you were talking earlier about, especially in the early days, there were lots of tasks like, the game day you were talking about to make sure that the infrastructure was up for scale. I'm curious if you've noticed in your time in Amazon as it's grown and the engineering culture has grown so much, are there any tips or tricks you've seen on how to grow an engineering culture and keep it moving quickly, keep it effective?
Well, given that Amazon is in reality my first real job, for a long time I thought that the rest of the world was just like Amazon. And it's not. There's a very unique culture at Amazon, I think, that works really well for fast-moving companies. And that is to build your teams as independent as possible, to remove as much hierarchy and structure from your organization as that is possible. Hierarchy, in my eyes, is totally unnatural. I mean, you need to have some form of hierarchy maybe for reporting or things like that or for some management pieces. But, if you look at nature, there's a head monkey and all the other monkeys. There are no lieutenant monkeys. Yeah? And so, no. I mean, you may have multiple groups of this with their head monkey, but there is, and it scales really well. I mean, if you look at ants and also to other patterns in nature, if you're able to build a self-organizing organization, which means basically that you hire people that really want to be independent, not want to be followers, that actually want to own a piece of the product and actually take ownership on that, I think that's extremely important when you're a younger business, where you don't need followers. You don't need just coders. You need people that want to have ownership over the piece that you want. And I think, look for that. There is something at Amazon that we call the leadership principles. There's 14 of them. And basically, that's all around culture. And so it's customer obsession, ownership, dive deep. And so there's 14 of them. Check them out. If you type them in your favorite search engine, you'll find them with a deep explanation of all of them. But that really drives what the Amazon culture is. And so when we hire, let's say when you bring in someone for an interview, you probably have really figured out whether he or she is a good enough engineer through the phone interviews and things like that. Your interviews are all about culture. It's really, do you have a real good culture fit? Because there's nothing worse than a bad hire when it comes to sort of the culture kind of environment, because that sort of disrupts your small teams tremendously. So at Amazon, we're a strong believer in very small teams, so 10 to 12 people. Because with 10 to 12 people, you're still, everybody knows of each other what you're doing. Yeah, and I mean, by the way, if you run Scrum, if you want to stand in the corridor in the morning with 25 people, that doesn't work. Yeah, and so you're really focusing on small teams and making sure that they have strong ownership over the pieces that they need to do. And so, one of the building teams that are independent thinkers, have control, want to have control over their own destiny, I think is important. I think one of the challenges is when you grow as a young business, often, I mean, the role of a CTO originally is probably that he does everything that has to do with tech. It's basically think about the technology, but also manage the teams. Now, I think managing teams is a completely different discipline. Now, there's a major difference between what I would call a VP of engineering and a CTO. The VP of engineering every morning wakes up thinking, do I have the absolute best team? Is my team in the best position to deliver what they need to deliver? It's a people person. Yeah, and really thinking about making sure that your engineers are in the right position to deliver the technology the products that they need to deliver. CTO thinks about technology. Are we building the right technologies? Do we have the right tools? Do we have all of these kind of things? So it's a very different job in my eyes than that of a VP of engineering. Yeah, so I think as do you guys know Michael Lobb? Rants, I think is he well known as sort of the blogger, write his pieces. If you're a manager, if you think about managing, I think in terms of technology management, he's probably sort of the most well-known modern writer that really thinks deeply about how do you make teams effective. And that's a very different, but he's not a CTO. He's a VP of engineering. And so I think that sort of really embodies that, and he wrote books about it as well. So really check out his stuff. Michael Lobb, Rants is his Rants and Response, I think is the blog. So really check those things out.
Great. So you mentioned earlier that in sort of the early days of Amazon, you had those companies integrating with you, and they were failing for the infrastructure reasons. And then, so is that where AWS came from? Or tell me, how did the idea for AWS happen? How did that get popular internally?
Well, so internally we're the Amazon the retailer later and AWS as well now are more or less organized in such independent teams that most of those teams look like startups as well. Yeah, or they have complete control over their own destination. And believe me, the recommendation engine for books is very different than the recommendation engine for shoes. Yeah, and so they have a different team, they have different goals, they have their own innovation agenda, all developed by the team themselves. By the way, so what we'd gone through a number of architectural changes. So end of the 90s, so Amazon's goal was to get big fast. And you were basically violating all sorts of architectural principles to get to that point. That meant that it ended up with some sort of monolith and a massive database infrastructure in the back end that was very brittle and basically couldn't grow anymore from an architectural point of view. So, but remember that nobody had done this before, so they can't be blamed. It's not like you're violating the textbook. There was no textbook. And so then Amazon moves to what's called a service-oriented architecture. That was not a word that existed around that time either. So carving off pieces of the monolith, bringing them together with the data that you operated on, putting an API on it, and then have a network infrastructure that you can call these, what we call services. And basically that took 2 to 3 years to get that done. Mostly because there was, again, no history around how do you run services. And so basically by what we were doing, we were swinging the pendulum all the way to the other end. So in this one, with the monolith, the whole set of databases were a shared resource and basically the constraint. Yeah, because shared resources are the thing that sort of make you move slower. What we saw, one of the reasons for changing architecture was that we saw that the effectiveness of engineers was dropping off. Basically, deployments were going slower, new features were getting slower, all these kind of things. And why? Because the backend databases were managed by a group of DBAs, so database administrators, the DBA cabal. And to make any schema changes, you had to go through them. And these guys were responsible for these databases. So they were as conservative as that you can imagine. Yeah, because the reliability of the site depended on them. So that saw that our effectiveness in innovation was really dropping off. And so moving to this new architecture, we created all these teams that were going to be independent, that they would have their own data stores. There's no longer a centralized data store. There's no longer centralized resources, things like that. So, oh, great. Except for that, we made some mistakes there. So so 2, 3 years later, we carved off all these pieces. The monolith is largely gone, all services. Turns out that's a side story. We made a mistake we had 3 very large data sets, customers, items, that's the catalog, and orders. And we basically had taken all the code that operated on that particular data as being one service. Within 2 years, that was as big as that the monolith was. Yeah, so we had to decompose into much smaller functional building blocks. For example, if you talk about the item master, the customer master service, that basically consisted of 10 different smaller services, each with their own unique scaling and reliability capabilities. Yeah, so, for example, there would be a login service in there that basically is called on every web page, but in that same piece of software also set the address book service. That only is needed when you check out. And so, but that whole thing needed to scale at the scale of the login service because that was the one that required the most scale. So decomposing that into different building blocks that each have their unique scaling and reliability and maybe security requirements made that we went to what now is called a microservices architecture. Okay, so move forward. All these teams they're small, they own their piece, and then we see the effectiveness of these teams tapering off again. Because what happens that each of those services now needs to scale. They all need to work on the same thing. They all need to manage load balancers, hardware, databases. Each of the teams now is responsible for actually replicating the database over three different data centers. So actually, all these teams, you see the communication between these teams and the networking infrastructure increasing. There's all these new tickets being created, all this work being done, but they're not working on innovation. They're not working on keeping the experimental pipeline going. And so there was another red flag, and what I realized was that all these teams were doing the same thing, because we'd swung the pendulum to that side, that now you had to manage your own database. So dropping actually databases into a shared services platform, dropping storage, dropping networking in there, and for example, also making an environment where servers no longer were servers, but became virtual, and you could actually manage them. So I think we were really good in those days in terms of hardware provisioning. So as an engineer, you would go to a portal, you would fill in what you need. You need 10 more Linux servers of this particular size. An hour or two later, you would have them. And if you can imagine, at the end of the year towards Thanksgiving, spikes are 4 times as high. So you would have teams need a lot more hardware. If you then would go talk to them in January and tell them, why aren't you releasing any capacity? It was, there's this project coming up in March. So we thought, why don't we just hang on to it? And apparently just an hour to get capacity is not a good enough incentive to sort of release stuff again. So we needed to go to a model, first of all, where you could take engineers out of the loop, and where you could have business rules that decide how much capacity is applied to something. So things needed to get servers needed to become virtual, they needed to get an API, things like that. So we built these things for ourselves internally. One look at these companies that were failing on the outside that required scale, we looked at, but we solved this for ourselves. Then starting to think to take some of those technologies, or not the technologies themselves, but thinking about how we had built them for internal, and then rebuild them on the outside. So the first one we launched was Amazon S3, the simple storage service, in spring of 2006. Storage for the internet is what we called it. And so really in the early days thinking that this would be targeted at what I now would call internet scale companies. I don't like to use the word startups, because I think there's many other types of businesses that eventually required internet scale, and that was really sort of where we were pushing for. Storage became the first one. We launched EC2 in the fall of that year. Same kind of model and interfaces that we used internally, where suddenly compute capability became programmable. Within a few months, enterprises figured out that this was way too good a deal for them as well. And we know what the story is since then.
So I am curious, I mean, at the time as you were developing this, before it was released, did Amazon have a sense? I mean, it's a dominant product now in the world. It's changed the way developers work at small and large companies. Did you really have that belief coming in, this is going to change the landscape, or was it just sort of like an iterate every year, more people are using it, and it just slowly grew into what it is today?
I think one of the things that we were, I won't say caught off guard by, is that how fast it grew. That was definitely. Did we know it was going to be really big? Yes, that was the bet that we were making. So at Amazon, there's 2 types of innovation that happens. One of them is that each team by themselves is in charge of the innovation roadmap for the coming year. So teams do that for themselves. So as I said, the recommendation engine for shoes, who has as a metric to reduce the number of returns. So can you recommend? So if this Valentino's 9 fitted you really well, if you want to buy this Jimmy Choo's, maybe you do an 8.5. This seems silly, but it's, doing returns is a tax, is a customer unfriendly kind of thing. So the more you can do that. So those guys are in charge of building a roadmap for the coming year, how to get new data sources, how to maybe engage with your customers differently. And that's something they make up themselves. And there's no top-down saying, and thou shalt do this. So that's one level of innovation. The other level is the one that requires significant capital investment. And that was clearly something that AWS falls into that particular category. Things like the Kindle, Amazon Prime, others are all things that to do that, we needed to do significant capital investment. And then at Amazon, we have the rule that if you do that, if it's going to be successful, it needs to be successful in a way that has significant impact on the Amazon balance sheet. It's not that we're interested in another, let's say, that sounds coy, but another $50 million opportunity. No, where if you make this capital investment, you need to look for really big opportunities. So we knew that if AWS was going to be successful, it was going to be massively successful. In a way that sort of we'd never seen before. We knew that we had to develop lots of new processes and technologies and techniques and whatever for all of this, if it was going to be successful. Now, I remember when we were developing S3, we wrote a number on the board that we thought, and within 6 months, we're probably, let's build this for this number of objects in the storage engine. And then just for the heck of it, we put 2 orders of magnitude behind it. Okay, blew through that in the first 3 months. Yeah? Now suddenly it turns out that sort of, that some decisions we made early on, from a technology point of view, were really smart. We knew that if you would, with every order of magnitude of growth, you probably need to revisit the architecture that you have. So you need to build software that needs to be able to evolve over time. And for example, take a storage engine. If you go to the next release internally of your software, you can't just copy the massive amounts of petabytes that you have on the other storage disks to do this. No, so you have to live with multiple architectures at the same time, multiple versions, all these kind of things. Fortunately, with all the lessons from Amazon.com, we'd actually taken the right steps there. But there's been some challenges over time in that sense. But I think also, just like with any other company, it's not only the tech that you have to scale. When I think early days at AWS, I believe we said something like, we don't need any salespeople. This stuff will sell itself. This is all self-service. Well, turns out that's not the case. It turns out you need solution architects, you need technical account managers, you need customer support, you need all these kind of things to build around your product that have nothing to do with the tech itself. But you cannot become a successful company without that.
I was looking just right before this interview, actually, and I was looking at sort of the AWS directory page, and there's, I don't know, I think it was like 130 services, and probably that number will change, by the time we finish this conversation. I'm curious, how do you, as an organization, determine, how do you decide to build something new? Is it a top-down process? Is it just an individual team? What does that look like to launch something new?
I think there's, it works both ways. I think there is, we expect all of our teams, as they are now, to be in very close contact with their customers. So about 95% of features and services that we deliver are in response to direct requests from our customers. And so that's a massive influx. Of course, the earlier services that we built, you could almost think about what they should be. What is the basic IT infrastructure, storage, compute, databases, network, security? That's, you didn't need customers to actually sort of tell you that. We knew that those were the basic pieces that we needed to build. But pretty quickly, customers came with all sorts of other requests. If I look at the sort of kind of things that AWS does really good at the fundamental level, it is scale, performance, security, reliability, and managing cost. Those are not products on the outside, but those are sort of core capabilities that come back in each and every one of these services. And so customers then came to us and said, well, can't you run analytics for us? This is the early days. So everything about analytics, around IoT, about mobile development, about these days blockchain, all these other technologies that customers actually want to use, but do not want to manage themselves. And as such, helping them sort of putting up the right features or tools is important. And we also had a very strong culture around when we launch new products, new services, we will launch them with a minimal feature set. You could call it an MVP. But this is technology where other people need to build their business on. So you can't actually launch things that are flaky. It needs to be rock solid. So we launch things rock solid with a minimum feature set and then work with your customers on what should the other features be. Now, in general, we already have an inkling what the other features are going to be. When we launched DynamoDB, for example, we really knew customers wanted secondary indices. We didn't launch with them, but that was obvious that was what they wanted. Mostly launch with a minimum feature set because these are sometimes services nobody else has used before, nobody built. And so you need to observe your customers, how they're going to use your product. Because you don't know up front. Actually, they probably use it in every possible way, except for the one that you intended it to. That is good. Because if you didn't launch with everything in the kitchen sink, then sort of you can focus on how your customers are using your product and then slowly start to iterate and adding new features and services to it in the way that sort of their new modern way of development is working. Now, when we launched Lambda, which is our serverless environment, so basically you just write code, you dump it in S3, and you can you don't need to think about servers and anything else. You don't need to think about idle time. You only have to pay for what you use. Things like that. Great environment. Nobody done that before. So how is development going to change? Well, there's a kind of other support structures around it. Yeah, originally, maybe we launched it much more as an event-driven environment. So a new file arrives in S3, it triggers some code. A new message arrives, it triggers some code, API gateway, things like that. But it turns out, some of the companies that actually immediately jumped on board with serverless were some of the largest enterprises. Why? Because you don't need to manage anything. And you don't need to pay if no execution happens. I mean, if you run a whole batch of EC2 instances, whether you use them or not, you're being billed for them. And in this case, you're only being billed for execution. And so it changes the way the development happens. And so you don't launch everything and the kitchen sink, I said earlier, around servers. You're going to see how your customers are using this. And then you quickly start iterating. We delivered X-Ray as being the debugging environment, delivered step functions to build more complex applications. And there's a lot of more things coming down in that pipeline, mostly because you can observe how your customers are using your product. So, for example, in DynamoDB, we knew secondary indices. Turns out customers wanted row and item levels access management. Much more important for them than secondary indices. So basically, customers reordered our roadmap to be able to and then we started delivering the things that mattered most to them, which I think is an important part in this. But again, even though it looks like an MVP, we can't treat it like an MVP because people will be building their business on it and will be depending on it. So it comes with a very different culture structure around it. So last year, 1,400 new features and services. As the number of teams grow, that of course accelerates as well. And so we use within AWS sort of the same structure. The Neptune team, the graph database, is supposed to be in contact with their most important customer or most, let's say, demanding customers and understand what their needs are. And so each of these teams has their own customer set and customer base and all build their own roadmap. The more services you get, the more roadmaps you get. But this is really a very fast-moving environment where the way that people are building software is changed dramatically as well. If we would have sort of taken the step in deciding for our customers how they should develop software, you probably would have been developing software in, let's say, the way that 5 years ago software or 10 years ago, because that's sort of the structure you have. Instead of it, we need to start developing software how we would like to develop software in 2020 or 2025. That's kind of the thinking that we have. And you can't do that by deciding for your customers. You need to work closely with them and allow them to sort of drive your innovation engine.
About a decade ago, you wrote a blog post called, I think, Working Backwards. You remember the one I'm talking about?
Yep.
I'm curious, could you describe sort of the product development flow that you put in that post, and then tell me what you learned and whether Amazon still uses that structure?
We use it everywhere. And so the post is called Working from the Customer Backwards. So at Amazon, we have a very strong focus on sort of developing only those things that really matter for your customers. Even though we're a technology company, and I think if you're a heavy technology company, lots of engineering, there's a risk that the engineers get in charge. Yeah, if they get in charge, you do not necessarily build products, you build technology. And so for us, I think there's a big difference between the two. I think what makes AWS, for example, successful is because we focus on products, meaning what do we want to build for our customer? Much more like, oh, this is this very cool storage system that sits underneath there that we've never built before, or how do we do global tables in DynamoDB, or so this is all this amazing tech that we're building, but that's not what's driving it. It's what do you want to build for your customer? What is the problem you want to solve for them? So we want to make sure that, and whether that is in AWS or whether that is in retail, or whether it is opening a new office in Menlo Park. We use a process called working backwards. Why are we doing this? So the first thing you do is you write a press release. And there's not a press release that will go out. This is a press release you write for yourself in which you describe in very clear and simple terms exactly what you're going to build. And then you write a document with, let's say, the 20 most frequent questions. And then you have to answer those in very clear and simple terms as well. Sometimes, especially for more complex situations, we iterate on those first two documents maybe 10 to 15 times until it's really absolutely exactly clear what you're going to build and not more than that. Then you write the UX document, basically how are my customers going to use this, or what is the interaction with the customers going to be. And then the fourth document is part of the user manual, glossary, and some other terms, things like that. At the end of that, you have a set of 4 documents that describes exactly what you're going to do. And then the ruling within Amazon is that, and thou shall not be built more than that. Because as engineers, and I'm one myself, you have the tendency to sort of anything that makes it easy for you to build version 2, you might already start putting that in version 1. That's not an option. Yeah, it's really focusing on building that and exactly only that. It gives us a really strong structure around how to think about customers, how to think about products, much more about technology. So this is the product you want to build. Now, what kind of technologies do we need for that? So there's a very strong product thinking around that. It combines with another process that we have. So meetings at Amazon, we have a moratorium on using slides. So no PowerPoint, no keynote, nothing like that. Why? Because in meetings, I think slides are deadly. Half of the room will be on their phones. And the other half will be already complaining by slide number 2 that they don't understand what you're talking about. That's obvious because you haven't seen the whole presentation yet. So we operate in Amazon with what's called 6-pagers. This is a 6-page document, a narrative that you have to write. And the first 30 minutes of a meeting will always be spent by reading this document in complete silence. Sometimes halfway through the reading, you go like, guys, go back to the drawing board. Don't waste our time here. Because why? Because it is very important, because it's very hard to write a clear document if you do not have clarity of mind. Writing a narrative is extremely hard. And this often a collaborative effort. You'll write it, you give it to some of your colleagues for feedback, you put it in your drawer, a week later you pick it up again and you revise it until you get to a point where you think you're really clear about describing whether it's a feature or a product or an activity or a new business that you want to go into. And after reading those 6 pages for 30 minutes, everybody in the room is on the same page. No pun intended, by the way. Yeah, or pun intended, whatever you want to say. So you get a very high quality discussion after that, because everybody knows exactly what we're talking about. So now, often part of that process is then as an addendum to the 6-pager will be the PR and FAQ, and you'll iterate on those. So we have a very unique culture around that.
5 years ago, virtualization was still pretty new. A lot of companies were just moving to that. Today, everything is being containerized. You have lots of big customers moving to Lambda, to sort of totally serverless platforms. Where do you think development is going to go 5 years from now? How are we going to be building our apps?
If I would have this crystal ball, I would be sort of... I do think I see quite a few companies skipping the container step more and more. Not that I think, so I think there's I think some part of the part of I think makes containers popular, one thing there is everybody wanted to go to a more microservices environment, and I think that maps really well sort of with container technologies, where you can scale things up and down easily in the single components that you have. And so I think that matches the microservices thinking really well. I think most of the people that actually come into that phase often come out of the monolith phase, sort of the breaking of the monolith into sort of those containers. I think people that start from scratch more and more develop around sort of serverless environments. And so you could even consider, so for we've at AWS 2 container products. One is ECS, the Elastic Container Service. It's all around Docker and Docker capabilities and things like that. And deep integration with all the AWS services. And then there's EKS, which is a managed Kubernetes service. And so that's how we started off. The thing with containers is, especially before we delivered Fargate, and I'll talk about it in a minute, is that basically it almost brings you back to the pre-cloud days. Suddenly you need to manage multiple containers over multiple availability zones. There's almost so much, then you need to map them onto virtual machines, because these things don't run by themselves. You still need to manage the whole virtual machine environment underneath there. So even though containers is a great sort of development abstraction, customers needed to do a lot of work to run those containers. So part of that will be taken care of because it's a managed service. We also delivered something that's called Fargate. So Fargate basically takes away all the management of virtual machines underneath there. So basically, just write a container, you drop it in there, it runs. Kind of. That's the state where you want to be in. Yeah, I think every time when you need to do things that actually have nothing to do with building your product or running your product in most efficient way, then that's sort of a waste of effort. And so we continue to look at how can we take more and more of those pain points away, because you know what? Nobody cared who were running containers. Nobody cared about the virtual machines underneath there. Yeah, it's just the tax that you had to pay. And I think we're sort of bringing up, especially I think the interaction in the Kubernetes group is really feeding many things back into sort of the mainstream Kubernetes open source environment, especially when it comes to things like security and things like that. So how are we doing things differently 5 years? Oh, that was the question. I think there's a lot more serverless development, because I think we see already an enormous pickup in and around that. I think we'll see more and more tools and sort of support platforms in infrastructure around the ability to build more complex serverless environments. Better integration, I think, with other services. That's definitely things that we'll see. But I want to shift to something else. I think one thing that we will be doing, I hope, 5 years from now, is that everybody will be taking security as their number one job. Whether you're the CEO, whether the CTO, whether you're an engineer, we all need to become security conscious, and we all need to become security engineers. I think if you've looked at the past 4 or 5 years, I mean, there isn't a week that goes by where there is not some massive data breach. It's embarrassing. I think us as technologists and as digital business leaders, we should be embarrassed. But we are not. Where's the outrage? We almost seem to accept this as being sort of part of our business. It's not. Without protecting your customers, you have no business. And I think and this is something that maybe as a young business, as a startup, you didn't think about 10 years ago or 5 years ago, where I think everybody needs to start with thinking about, oh, this is the kind of data I'm collecting from my customers. How am I protecting my customers? And you may say, oh, who is interested in when Werner rented this bike here? Well, you know what? That data set plus 2 other data sets that you may get from other places may have a very valuable position. So I think we all need to become extremely security conscious and make sure that we can continue to protect our customers. It will be embarrassing, I think, as young businesses to actually start losing your data of your customers. It will impact everybody else in your environment, not just as customers, but it will reflect on other young businesses as well. And I think if you collect data of your customers, if you have consumer data, you have a grave responsibility to keep that data secure. And there's also tools for it. So there's encryption, and we give you dozens of different tools that all can help you do this. But you need to keep it in your mind that that's your first and foremost job. Of course, you all think, yeah, but we don't know. We're building this new service. We're building this new consumer service. We don't think. No, I think the only way, if you actually build your new business without security in mind, it will be very hard to retrofit it into it. Yeah, and so you will have a nightmare, let's say 2-3 years down the road when you become successful and you grow and you need to retrofit security. You're going to be in a major mess. So it means also that your development processes, because that's what you asked about, need to change. Security needs to become a default part of your, for example, your continuous integration and continuous deployment pipeline. Yeah, it needs to trigger events. Whenever you're building something and someone adds a new open source library to it, an alarm should be going off for someone to inspect. Why are we adding this? Why are we doing this? Did we check this out from a security point of view? And so your development pipeline itself needs to be secure. There needs to be all sorts of alarms going off in that whole section. And security needs to become your first and foremost concern. Then there's lots of automation tools around it. Yeah, so you deploy, you can use Amazon Inspector to test about all sorts of vulnerabilities. But if you do continuous integration, and continuous deployment, especially if you, for example, in fintech or in healthcare, you're subject to also to regulatory requirements. How do you know that these new next 5 lines of codes that you just wrote don't violate your HIPAA? Yeah? Or that you're still in compliance with whatever the financial regulator wants from you. So you have all sorts of automation tools that can continuously test this for you, but you do need to do it. And it needs to be in your mind. So development, especially if you do continuous deployment, changes radically from how we've been approaching security in the past. Now, I honestly believe continuous deployment actually is better from a security point of view, because in the past you would write 50,000 lines of code, security team would come in, would review it, would bless it, and they had no clue what they were doing. They would bless it, 50,000 lines of code, you have no idea. Yeah? And then you would deploy it. Changing 5 lines of code is something that you can actually test with automated processes and automatic reasoning and things like that you actually are building the right thing. So I think it is great advances for security. We do need to keep security in our mind. So I hope that in 5 years' time, we're not necessarily all security engineers, but we're all super security conscious, and protecting our customers will be our first concern. It is at Amazon. It will be forever our number 1 investment area, both in terms of intellectual capital, as well as sort of in financial capital. Without protecting your customers, you do not have a business.
Beyond not taking security seriously enough, are there any other common mistakes or errors you see startups doing as they use AWS?
Well, first and foremost, I think there's a technical one. So we've got quite a few people that are for the first time AWS users, but that have already had experiences, let's say, building services and using a traditional data center. Using AWS as a data center makes it you lose out. I think, yeah, there are some advantages to it. You have some elasticity and things like that you can make use of. But if you don't use sort of the higher level services around security, around data analytics, around mobile, all of these, where we take away a lot of the development for a lot of the hard, let's say the heavy lifting, you're losing out. If you just treat it as a data center with just some virtual machines and databases and storage, that's not where your major productivity improvements are going to come from. Some, but not the major ones. Next to that, sort of more of a meta level, you have to figure out what kind of company you are. And I think there's sort of 2 different companies, two different styles. One of them is, you go for the high growth, very fast, get big fast kind of thing. Acquire as many customers as possible, as quickly as possible, not necessarily thinking that much about revenue, taking lots of investors' money and really get big really fast to become successful and then probably be acquired. Because that's why people invest in you. That makes your use of AWS and your use of cloud very different from and we support that really well, because you don't have to worry that much about getting capacity or services, whatever. It's all there. And it comes with a clear cost picture as well. That's different. Or if you want to become a sustainable company, basically I want to build this company, but still be in business 30 years from now. Not necessarily focused on acquisition, but just building a business. I think if you guys follow Signal and Noise, the guys from Basecamp, DHH and others and Jason Fried talk a lot about how they build a sustainable, how they want to be in business still. They want to still do this business 10, 20 years from now. How do you do that? And that's a very different, that requires different architectures. It requires much more control over cost. It requires a clear association between cost and customer acquisition. So AWS supports that as well, but it requires you to build very different architectures. Yeah, because you want to have much more control of cost and scale than in the other one, where you're not much concerned about cost, but you're much more concerned about sort of, can we change really fast so we can address our customer concerns, because we need to grow really fast. Jeff often makes the distinction between mercenaries and missionaries. Yeah, mercenaries are the startup founders that are in it for the money. Yeah. And missionaries are the ones that are in it for the love of the product. I want to build this product, or I want to build this business. And you support both of them. They're both valid. They're both valid approaches to entrepreneurship. It's just that the tech support and the tech that you build for each for these different groups is very, very different. So figure out what you are.
All right. Well, thank you so much. This has been wonderful, and we've learned so much. And thank everyone. A big thanks to Dr. Werner Vogels for his work.